Hi, everybody. I'm Michael DiPanino. I'm also known as the data guy on TikTok, and I get to be your host for today, or this session. I think that in many ways, this room has the most ironic title, which is, or at least the beginning part of it, which is that it's a remote collaboration room, yet we are all meeting in person, so something to think about. But I will try to bridge the gap between these sessions, but mostly I'm just here to introduce people. But if you guys have questions along the way, or the ideas, do reach out to me. This is, to my left, Christopher Palmer, or Dr. Palmer. He is an ecological scientist and combat developer, refining, testing, and delivering advanced technology against critical capabilities gaps for soldiers and small units. In a survey we conducted just prior to this, when asked, what is one item that you would take with you, or that you would bring with you if you were deserted on an island? Most people said you, Chris. Okay, that's my morning joke, and I'm going to pass it to you.
Seems unlikely. Can you guys hear me? Thanks for coming this morning. I am going to talk about the opportunity and challenge of mixed reality for the warfighter. Not just the warfighter, though, for others in similar situations, which we'll describe, and with the hopes that investment from the DoD in this space can help make the technologies and the capabilities we're going to talk about more accessible to others in this space. So if we look at the left-hand side here, the context is really about laying in mixed reality into soldiers who are wearing night vision devices, search and rescue teams, mountain, maritime, or urban, disaster relief people, or firefighters, all of which share some common situations or contexts. We'll start and end with context. And the critical situations just means that there are temporal constraints and consequences for not getting the task or job done on time. For all these people, it generally entails a loss of life or a loss of survivability. So the promise of mixed reality in this space is to improve survivability across these and other similar situations. One of the challenges is that all these contexts are folks who have perceptual encapsulation through the PPE they have to wear while going into the tasks they have to do. So from helmets to communications and hearing protective equipment, eye equipment, respiratory equipment, and then all fire equipment, all the loads that go on that restrain the natural perception capabilities. So one of the other promises of mixed reality is to enhance the situation or to potentially give back situational awareness in different dimensions of perception that they would not otherwise have. The mobile human teams in terrain, very important. These people are moving through the environment. They're actively engaging with tasks and moving over mixed terrain. It's not like sitting in platforms, whether they're ground or air, and it's not like sitting on couches from computational power to distributed data management. So what we're trying to provide is data to decision to people who have increased physical loads, right, the amount of equipment they have to wear, and increased cognitive loads, not just from the stress of the situation, but if done wrong, potentially increase cognitive intentional loads from mixed reality that's not portrayed in appropriate manners. So the promise is that increased clarity in the fog or tragedy can help save lives. Let's unpack this a little bit. So we'll use earthquake rescue as an example, but why is mixed reality catalytic? Well, mixed reality in a lot of ways provides a bridge between the human and other technologies in the ecosystem, whether it's a robot on the upper right that climbs through rubble to find people, LiDAR or payloads that can detect and penetrate the ground, or physiological monitoring systems that allow for remote understanding of position location information and physiological status. So from this mix, you can get a shared understanding of team events and objectives that you wouldn't otherwise have. Right? It's a much clearer communication about ongoing events and tasks that, if done correctly, can happen nearly instantaneously, despite the fact that people are not co-located. Certainly does extend perception, right, through sensors or other modalities, but in these conditions, we still have a vast reduction in perception in the first place. So part of the chore is to return some of the perceptive capabilities that are lost from protective equipment, and the others to enhance them in different directions that aid to particular tasks. All of this really requires a good bit of machine learning, AI, and other sensor teaming, which really gets into how you're going to deliver this kind of capability when you don't have a platform and all the power and computation, or you're not sitting at home with all the power and data that you need. So it's really going to give us better data to decision in a real world view that you wouldn't otherwise have, right? And if you can do it faster, you can potentially save more lives or get out of critical situations with less injury. So let's give some simple examples of this. On the upper left-hand side, imagine using mixed reality to look through a disaster site, right? And understand that when you couple it with physiological monitoring and position location information, the green, yellow, red, and orange dots representing basically a non-co-located triage, right? So where are the people and what's their status, right? What that can help is, how can you tell the people who are digging through this to try to save lives where they put their energy? Where is the easiest juice for the squeeze? Where do I put these places? And what kinds of different equipment do I put in these places to get not to the red, but to some of the green, yellow, orange, the most critical you might want to get to first? On the upper right-hand side, we have firefighters who have to, cartoon firefighters, albeit, looking through smoke with digital night vision, but having an understanding of the structure they're in and potentially where people are located, right? And what's the best route to get there and how do they get there? Now, you also notice I put in help on purpose because we're going to talk a lot about the visual mixed reality, but oral or hearing mixed reality has a lot to gain and a lot of work to do in this space if we're going to really reduce cognitive load, and we'll talk about that in a little bit. On the bottom here, this is a boat driver scenario, fast boat driver scenario. I know it's a platform, but hear me out for a second. Generally, what you get is a map for navigation that's down on your screen, right? You got to look down, look up, reorient yourself, then make a decision about which direction you want to go, in addition to what objects you have in your space. So the heads-up display is supposed to allow people to look through and see exactly what they need in a combined space in the local and global coordinate system, right? You embed those together, mixed reality, you have much better decision-making and faster. The challenge is how we portray that information. So traditionally, or to date, there's a lot of maps in people's faces. So taking the map from here and putting it here is maybe a logical first step, but at some point we're going to have to get to specificational information, which really is about information that specifies particular actions, right? And in doing so, reduces cognitive load and all the transfers you have to do to figure out what did I just see and what does it really mean for action. So if the advice is turn the boat towards the green arrow until the arrows disappear, you can then navigate, right, without having to translate where I am on a map, where my dot is, what my heading is, what's the local contingencies, i.e. buoys, other ships, fog that I have to navigate through, and just trust the system and move through here. Trust is a big word. So the specificational information in lawful is very important because it's the way in which you portray information that makes it directionally actionable. You can't always get directionally actionable, but the closer you can get to that, the more usable and the less cognitive load you place on the user of the system. So I didn't show any soldiers yet, but from a soldier scenarios, you can think of all of these, a soldier medic in a mass casualty situation, right? In any small unit, depending on the size, you have between 2 to 4 medics. When you have really bad things happen, you can understand where on that distributed battlefield the worst case scenarios are, where is the best place that those medics can go to, the routes they need to get there, and then how do you portray it in a way that's consumable for the human to immediately start acting, right? So you're compressing time, you're making it more actionable. In this case, you're saving golden 2 hours or the golden hour. Some of the challenges we face, right, is that in these scenarios, we have much more dynamic movement of the eyes, head, and torso over that mixed terrain, faster speeds as the system's moving, and much lower computational power and processing. So in the upper right, you see a HUD display from a fixed wing platform where all the computational power and data processing and algorithms can be done on this giant platform. On the soldier, you have to distribute that data and power platform processing across that small team and the small element. Right? Even in disaster relief, sometimes the 5G and the entire systems are down, so they have to be somewhat co-located. This leads to very big challenges in the head-borne cognitive and attentional load. And so what do I mean by that? Is that if you contrast the current capabilities in fixed-wing platforms with the bottom right, which is the Iron Man-ish what we're going to display for humans, you see things very differently, right? And so this idea that we can put all this information, right? You see some text in there, right? You see another person, a bunch of analytics, and people are going to move through the environment and make decisions while basically reading a book in their face. It's unlikely to happen that way, right? It disrupts the perception-action loop that allows people to move and act in ways that sustain and enhance their task. Definitely mobility. And then the local global relations I'm talking about is the local relations, or what am I displaying on this HUD, with the global being the real world. So the tactical surroundings that I have is my global situation and then my local. So you get into a lot of local global dynamics about attentional switching and when do I portray information. How does this all happen in a way that delivers information that action can actually occur to improve the task or outcome, increase survivability, get to the people in time, get that medic where he or she needs to go, all of those things. So what this really comes down to is the human environment, machine, task, display, XR system interaction. So what I've laid out here on the left-hand side really is about what the machine can do. Like what's the technology going to do? On the right is the way in which, so how do you get to lawful information, in other words, right? How do you get to a place where you understand what the lawful information is that you have to display? On the right-hand side is about how do you portray that information in a way that's consumable, and what are those challenges? And the bottom is, what's the context? What do I need to know? Who needs to know it? Why do I need to know it? And when do I need to know it? And then those things come together and say, what are we actually going to provide for the user to enhance their performance and where they need to be? So if you look at the left side here, you're talking about the control of the actual mixed reality device, the integration of different night vision sensors into a common display, right? Other sensor fusions, whether it's the UAV or the robot or physiological monitoring status. How do you pull all those data streams together, right? And then use your machine or directed learning and pull out information that's relevant in order to deliver it. And all that processing you're going to do on the body or in a tactical distributed network. And if you're going to do it in a network, what's the size of the pipe that you have to push all this information around? So where do you conduct local data and power processing, and what do you send to a larger element in order to integrate and fuse it together? Insofar as the individual in these contexts can't carry more load. They're already carrying between 40 to 60 to over 100 pounds of kit, and the powering processing just isn't there, not to mention the temporal lags you get for some real-time data to display. So this is really about how you get something to display that's relevant. On the other side, you're talking about the optical or the geometric alignment for your mixed reality system to the human eyes, right? Convergence, parallax, IPD, all those things that have to be basic and have to be in the right place at the right time just to perceive the mixed reality you're trying to give to someone. In these situations, you then have, because of all the movement, relative motion between the head and the glasses, goggles, or HUD that have some challenges with it. And then, unlike fixed-wing platforms, you don't have fiduciaries that tell you where head in space in global coordinate systems line up, right? And IMUs in these speeds, people are very familiar with the challenges of IMU and getting to position from acceleration. So lots of challenges as we ramp up the speed and move over terrain, and we don't have a platform. How we're going to get that same real-world embedding in these kind of conditions is still a major challenge to be solved. I've talked about the physical load, but more particularly, the physical load on the head has severe consequences on the vestibular system, right? So the visual vestibular comfort and challenges, not only in how you portray your information and whether your world-locked information stays where it's supposed to be, but whether your head-locked information stays where it's supposed to be as well. Drift, jitter, and all those challenges. On top of that, you have to have the challenge of nauseogenic effect and whether or not it's usable and for how long, under what task and conditions. So in the end, you have what it is I'm trying to display, how do I display it in a manner that's most helpful, and then where is that exactly? So what it really comes down to is that these are the interactions that have to be understood in this truly complex system, right? On the left, you have a very complicated machine system, and here you have truly complex systems, human and environment, eyes and head, cognitive load, ongoing physical stresses. You've got to start there and go backwards. And I just use this upper right to talk about what is it we're trying to show people and these users under what conditions that are really usable. So this is a breakdown of a fused thermal and low light condition where you can see the outlines. On top of that, we have, hey, where are all my friends and enemies located, the little dots in the circles, and then some statuses on the left. Well, how do we portray that in particular contexts? And how does that enable the warfighter, the firefighter, the disaster rescue person to go and do their job in a way that compresses the time and allows them to act quicker and more safely and hopefully save lives? That's the challenges that we have here that are much different than platform and much different than gaming when you put all these things together. So in the end, AR will definitely be a catalytic capability for soldiers, first responders, and rescue. It should go a long way to improving survivability and saving lives in the long run. And hopefully the investment from the DoD in this space proliferates the technology the way it did GPS and makes it much more accessible much sooner. Having said that there are severe challenges in this space in the real world. It doesn't mean that we have to go to the far end and have people running over terrain and trying to display this. There are scenarios between static sitting and moving in those scenarios that will still allow AR to be implemented much sooner than in the farthest end of the continuum case, for instance. But there's still high-end challenges about the ways in which we have to build the devices for mixed reality in this context, as well as how we portray that information, to include something I didn't talk too much about, which is visual oral mixed reality. And how do you make use of, especially in this situation where everyone's wearing hearing protection, how do you unload attentional visual load or cognitive load through vision by ramping up the ability to use oral information and spatial 3D awareness? Those things together, right, are really part of a single track. They're not now, but should be part of a single track to deliver information in the best way you can while minimizing attentional and cognitive load. This last one is, it's pretty true for everything. The aspirational and where we want to go is certainly important to put road marks down of where we need to be. But when we do these things, we have to meet technology where it is, right? So where we are with regards to real world embedding, where we are with task analysis, what task we think today's technology can actually solve. And equally important is that architecture, right, that underlines all of that so that once you get those minimal base cases, you can grow on top of that without having to redo the architecture underneath it. So your distributed data and power processing system, your tactical edge computational cloud packages, the ways in which you're going to portray and how all that works, the fundamentals of that, unless you want to rebuild it, have to be pretty locked in place, right? And from there, you can really start exploring how this works. And the biggest benefit is once you get that minimal product out to the warfighter or any of these scenarios, your next step will be almost defined by them, right? Just giving them some capability will help shape what that next step needs to be for the next investment in ROI, in capability or business. That's all I have. Thanks so much.
All right, any questions?
I'm Tiffany Raber. I'm with the Army Research Laboratory West, working on the XR COP. And from our standpoint is we obviously have our soldiers, boots on the ground, in a more egocentric view. They have low connectivity, but they're streaming up a lot of data points to the actual command post. And that's somebody in charge of hundreds of thousands of data points, and they're really the ones making the decisions. So have you thought about how information mediation will come into play for the person actually making the decision when in real life they're usually managing many squads and many data points?
Yeah, so I think if I understand your question right, so this is one of many contexts in the military and the ground warfighter. So one of them is certainly a common operating picture, right, from intelligence or medical or tactical, where you have senior leaders making decisions. I should have made it more explicit that This is really about the squad, platoon, or the people on the ground enabling their task performance and talking about those constraints and those challenges. When you talk about how you're going to flow information up, right, into larger decision-making constructs, company, battalion, brigade, there's a whole bunch of, you get relieved of some burden, which is now you are static, you can sit on your couch, you do have distributed data power process, but you also have infinitely much more information to manage. So I think as you go up those levels, that becomes the challenge of data fusion management, and then, but it still comes down to context. What does that command leader want to know and when they want to know it? Start there, you can go back to, okay, what kind of data streams do I need, i.e. devices? How does that person want to see it displayed? And then how do you put it on the kind of dashboard to merge it all together? Then you can start assigning algorithmic development responsibilities for what the priorities are in accordance with what's real for technology readiness levels, right? Does that make sense?
Yeah, that's exactly the mini problems we're dealing with.
I have no doubt. I can't see, so someone's going to have to say if they have a question or not.
Questions? Yeah.
So you bring up a lot of things that are looking toward the future. How can big tech help you now to get to the point where we can start training these folks before we can get a device on their headsets that's actually viable in the field?
Yeah. So I think there are programs like that going on currently, and certainly the platform folks have been working simulations forever. There is an ongoing program in the Army to look at small unit and soldier training in virtual environments, right? To use mixed reality in order to enable soldiers to perform better in the field. I think General Mattis called it the 25 bloodless battles, right? Let them go out and do their job in as real a possible way in order to get better at their job. There has been a lot of work in kind of mixed reality in the virtual, right? So you can do it all virtually and get some thinking and cognitive attention. What do I pay attention to stuff done in the virtual reality only. I guess I would only say is I think the next step that's maybe between those is display of mixed reality and virtual reality. So when you talk about data to portray and what you want to know, the best way to do that before you start cutting metal is to display information in a virtual world as if it's mixed and get much closer to the end ballpark decisions with the actual users before you start cutting metal and deciding what that looks like. I don't know if that answers your question, but there are some programs in that space already going, and I guess you just have to line up with the DoD.
I'm from Amazon Web Services, so I'm just trying to figure out how do we help you?
Yeah, so I guess PEO STRI and the synthetic training environment out of Orlando is the place you'd want to look for that. That's where all the training happens there. And I know they have ongoing programs and a lot of research and development efforts in the S&T as well as R&D space. So the science that underlies it, and then how do you develop and deliver it as you go forward.
Give it up for Chris. Thank you.